welcome to lecture 71. Here, if you remember, in the last lecture we have worked with the precession motion. Now, we look into the nutation motion. So, already I have told that this is a lunisolar precession, over that the nutation is riding. Okay. So, this perturbation motion is modeled in a similar way, and we can represent this nutation rotation, or nutation we have written as n. So, therefore, I will indicate it by n. It is the rotation matrix. Okay. So, this motion can be written in the form, first we give a rotation about the x axis by epsilon bar, this is called the mean obliquity, and then we give the next rotation about the z axis by minus del psi, and the last rotation we give about again about the first axis or the x axis by epsilon. So, this is your nutation matrix, nutation, rotation matrix. Here delta psi, this is called nutation in longitude, that means longitude for your vernal equinox, it is a moving on the equator because of this. And the delta epsilon, here this is not epsilon, this is okay, delta epsilon I will later on, this epsilon is okay here, and this is epsilon bar, both are okay. And what does then all they mean? So, it will be clear later on. Nutation in obliquity, that means inclination with the ecliptic of the equator, this changes. Okay, so, this is modeled as delta E. Okay, so, to model the nutation, we go on the next page. So, if we go back, we see that our axis has come to this point, this is your x axis finally, x axis was first here and then we finally moved. So, here this will appear as x triple prime, z axis has come here in this place, z triple prime is here, and similarly y axis will move to this place, somewhere on this equator it will move here in this place, this is the y triple prime. Okay. So, this black axis we pick up, and put here in this place, and again, but still we will write this as x y z. We will not write as x triple prime z triple prime. If you can write, but it is not very convenient carrying so many of indices, and this remains so. Okay. So, as per this already I have written here, this is the mean equator of det. So, here in this case this constitutes the MOD, mean equator of det. So, the precession rotation we have already given. Now, we have to go to the nutation rotation, okay. And as usual we draw the planes. And here your gamma is there, which gamma we have written as vernal equinox. This is the vernal equinox of 2000 and this is vernal equinox of mean vernal equinox. This is basically because this is mean equator of det. So, with this the mean term will come. So, this is your mean vernal equinox. And once we give the nutation correction, then mean term will drop out and then we get only vernal equinox of det. So, here you have the ecliptic as shown earlier. Okay, so, the nutation rotation as we have written earlier, this is modeled by R 3 and we have written as R 3 minus epsilon R 3 epsilon bar R 2 with minus delta psi was there, and then R 3 again we have taken with minus epsilon. So, that means the first rotation we have to give about the z axis by sorry, here this is R 1 and this is also R 1. About the first axis we have to give rotation by epsilon bar. So, the first rotation we give here from this point to this point and this is your epsilon bar. So, that means this axis will move from this point to this point. So, as a result of this point will move from here to this place. This will be your epsilon bar. So, this becomes z prime. So, motion is along this direction. This is a positive rotation about the x axis. The next rotation is given by minus delta psi and that is about the 2 axis. Okay, so, if we rotate about like this, so the y axis, this will go and get here in this place. So, this is your y prime and this is y, the y direction. Or this is 3 1 3, we have written earlier correctly. Here we have this is R 1 R 3 R 1. So, for the this is about the third axis, this is about the first axis and first axis. So, the first rotation takes it to this place, this is your epsilon bar. The next rotation we give about the z axis about by minus delta psi. So, that means what has been shown here. So, you have to rotate by minus delta psi, means by delta psi you are giving rotation in this direction, negative. Okay, this is a negative direction, you can see it is going over the blue line. So, as a result of this, the plane from here to here, this point to this point, this will move and come here on this axis. So, this angle then is your delta psi with minus sign. So, here also we can indicate this is minus delta psi, because this is in the negative direction. And as a result of this, this gamma point also it will move along this by delta psi. So, it goes here somewhere, say, and from this point to this point we can connect it. So, this is your delta psi, from this place to this place, this is delta psi. Okay. And the third rotation then given about r 1 by minus epsilon. Okay. So, this is your axis now, and about this axis you have to give another rotation by epsilon. So, another rotation by epsilon about this point, that means this pink line what we have shown here, this pink line, this particular line, now we have to move it, okay, by epsilon angle. So, here you have to give rotation by minus epsilon, okay. This is the negative rotation. Once we give this, so this line, then it will come to this place. Somewhere it will appear like this. This is dark blue line. So, this total angle from this point to this point, this is epsilon. And this we call as the so we have mean equator of date, and then it went here and then it came down to this place. This is called true equator of date. So, if we see here, see this is a very distorted figure actually. Okay, it is a highly distorted figure because these angles are very small. Okay, the what here epsilon is okay around 23.5 degree, let us say. So, this is okay, it is not much distorted, but our other angles are very small, and once we iso it like this gets distorted. So, here somewhere above this line, so what I will show that if this is the MOD, mean equator of depth, and true equator of depth lies somewhere it is like this, okay. And if we draw a parallel to the mean equator here, this angle is approximately delta epsilon. So, we have gone from this place to the ecliptic, from the mean equator of depth we have gone to the ecliptic, and from ecliptic we have taken a turn by coming from this place to this place by delta psi, and thereafter once we have given delta psi, then again we are dropping the ecliptic back by epsilon angle. So, this is going down by epsilon angle. Okay. So, this is shown here by this dark line or this line. Actually, this line is very much distorted, and therefore, it appears to go like this. Otherwise, in actual figure, if you look into some of the references, so actual figure should look this way. This is the mean equator MOD, and this is the true equator of depth, and there is a small angle between this, which is delta psi. This is MOD, and then this part is going to the ecliptic. Okay. And then from here, this is after the giving the correction delta psi, and suppose this is the part. So, and this is the center. So, about this center, then you are rotating by this angle is epsilon bar, and then you are rotating here by epsilon. So, this will get back and almost it will come like this, it will be going like this. See, this thickness is very large. No. This is our, I will first let us show this in the pink. Okay, so, this is your MOD, and then this is the ecliptic you have taken to by giving epsilon rotation, and finally, delta psi was given, which we have taken along the ecliptic like this. Okay, so, we are assuming that equator has came to this place, the x axis has come to this place, and thereafter about this axis we are giving the rotation. So, that rotation again it will bring back this from the ecliptic to below the equator by a small angle, okay. And that angle we refer to as, so giving this rotation, see the figure what we can draw using the graphics tools, and here it is not very clear. So, this will go like this, some small rotation. So, this angle was epsilon, okay, and then you are taking it down, okay, and okay, I will show it on some other figure where this will become clear. From here it is I am not able to make it using this thick lines. So, I will show it through some other figures, it will be much more better. See exactly what we have done, that this is the mean equator update. And this we show as equator update or the TOD, true equator update. This line is showing ecliptic update, so mean equator update, what we have done, we have gone by epsilon bar. Okay. And thereafter we came down by this is the ecliptic update. So, along this we have came down by delta psi. So, this was your vernal equinox of gamma we have shown mean vernal equinox. We are using mean vernal equinox, the people are not using this term, but for convenience let us write this as this is the point gamma. So, then we come to this place, and thereafter what we do, about this, then we are giving deflection by epsilon. So, this angle is your epsilon. So, that means this epsilon is epsilon bar plus delta epsilon. Okay. So, you can see that if this is the line here, this is the mean equator update, and parallel to this, if I draw parallel to this, if I draw this line like this, okay, these two are parallel, okay, then this angle is your delta epsilon. So, it should be clear from this place. So, which I am not able to make here because the angles we are taking large here in this place. So, it is not very much visible. Here also see once we have gone here, from here we are going down by epsilon. We went up from here to here by epsilon bar, and we are coming down by epsilon. So, the net rotation is as shown here, this is delta epsilon. Okay. So, this is called nutation in obliquity. Okay, on this figure we can also make the precision also can be shown on this line. So, say this is the mean equator of J 2000. and like this is the ecliptic update. So, here this is ecliptic of J 2000. Okay. So, this constitutes your gamma 0, the vernal equinox of J 2000. And from there then we have given the precision correction, and by giving the precision correction we got to the point where we got the MOD. So, MOD we have shown here in this place like this. So, this is your mean equator update. This is mean equator of date, and this angle we have shown by theta. You can see the conversion. Okay. So, the mean equator of date is here, and this is the line we are picking up. Okay. Again go back. So, the mean equator of date which is shown in here in orange. So, this one is picked up and the corresponding gamma is there. So, we have picked up this and this is the corresponding gamma. And then the next part we have moved it from to the ecliptic object. So, we are picking up the ecliptic object and okay. So, this part first we had the mean equator and the ecliptic of J 2000. From there we got this line, the mean equator of date, and also we have shown earlier the this part, this line which is the ecliptic of date. So, this is the point here which is referring to gamma, okay, this point. So, this is the point here which is gamma, and with this point then we start with, and from here then what we have done, then we are going to the equator of date. So, first what we did, that we have given here the rotation r 1 by epsilon bar, okay, which is about the x axis. So, about this axis then we are giving rotation by epsilon bar. So, giving this rotation by epsilon bar and then moving by delta psi MOD, ecliptic of date, and then okay. So, this is your, this part we pick up. So, this is given by epsilon bar, and then move by delta psi along this line. So, we move from here to here by delta psi along this line, and so this is your delta psi. So, both are combined together now, the nutation and the precision, and then again convert it once we have given this. Okay. So, from here if we show little bit delta epsilon upward, this is delta epsilon. So, epsilon bar and so this line and this line they are parallel. So, rotating about first bringing this point to this point and then rotating by epsilon. So, this angle is your epsilon and this angle is delta epsilon. This angle is epsilon and this angle is delta epsilon. We make it little darker. See, all the three curves are all the two nutation and precession, they are combined together. So, we started with J 2000 ecliptic of J 2000 and equator of J 2000 as it is written here here in this place. Okay. Then we came to the ecliptic of date and mean equator of date, which is shown by this line, and this is the ecliptic of date, which so we come to this point. So, this point and this point, they are the same, and this point and this point, they are the same. So, taking this point here in this place, okay, and then giving delta psi here, this rotation along this line, and then again giving rotation by epsilon, we get this final result. Okay, so, from here to here we have given rotation by epsilon. So, this rotation is given by epsilon, and with respect to this line, then this line makes it these two are parallel. Okay, and therefore, this appears as delta epsilon, and I hope that this makes it clear to you, and I will supply you the graphically drawn figure, as I can show if the camera can be focused on this. So, whatever the figure I have shown you the color, the same figure is shown here in this place. If you look at this place, this is the same figure. Okay. So, by giving the proper rotation on the board, this screen I am not able to draw very neatly, but here if you show graphically, it is drawn very neatly and all the angles are also shown. So, upper figure refers to the precession and the lower figure, here both the nutation and precessions are combined together, which I have shown on the screen. Okay. And so, we can wind it up on the there if you saw it on the paper. So, there it is just written r zeta a. So, do not go by that, because we have given first the negative rotation and that was about the third axis, and then we gave the rotation about the two axis by theta a. This is what we have done. This theta by theta about the 2, and then again we are giving the third rotation by about the z axis by minus z. Okay, so, this is by minus z. So, this is the actual thing on the paper, whatever was written in the pen, that is not corresponding to this. This was just symbolic, but here the correct sequence, the sequence with signs are given here in this place. So, this material I will provide you later on while the course runs, but this is the right figure, and let me draw it afresh, so that it remains in record here. So, quickly I will draw the figure. So, mean equator of date, and this is mean equator of epoch, MOE, we should write MOE J2000, and this is mean equator of date. This angle is theta. So, this angle will also be theta, and then we have drawn a line like this. This is gamma 0, here this is the ecliptic or fixed, this is called the fixed. I have used the word mean, but this is a fixed ecliptic of date, not mean, it is a fixed ecliptic of date. Here it is correctly written, ecliptic of J2000. So, this is point gamma 0. Thereafter, this is converted here, and then again we have the ecliptic of date. Once we have got the ecliptic of date, so we here the point gamma we are getting, and angle between these two, this we are writing as epsilon bar. Here in the on the paper it is written as epsilon bar is written as epsilon A. And finally, once the nutation correction is given, so this angle becomes epsilon bar plus delta epsilon equal to epsilon, and therefore, this is the equator of date, which also we write as the true equator of date, TOD. And this is your final gamma point. So, we will write this as prime. So, this is your final vernal equinox of date. And the distance between these and two, angular distance, this we have shown by delta psi. And there are various other representations, the angular representation we can write here, but those are not necessary. This suffices for our need. That means, coming from the mean equator of epoch or equator of J2000, this is the equator of J2000 to the true equator of date TOD, it involves the precession and the nutation correction. Once this is done, then we are ready to go into the terrestrial frame. So, today we wind up here, and then next time we will take up the terrestrial reference frame, how to go up to that place, and thereafter we will come to the orbit determination part. Thank you very much.